Let us learn coordinate geometry formula. This equation representing two straight line. You see the quadratic equation. If there are two variables x and y and its total power or degree is 2, then it is called the quadratic equation. General form of the quadratic equation is ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0, where a, b, c, f, g and h are the constant quantities. You see, a1x plus b1y plus c1 equal to 0 is number one equation. The second equation is a2x plus b2y plus c2 equal to 0 is the second equation. These equations represent a single straight line each. So here I have multiplied these two equations in order to get the product of it. You see, in each case the right hand side is equal to 0. So a1x plus b1y plus c1 in one bracket. In the second bracket I have written a2x plus b2y plus c2 in the second bracket, and the product is again equal to 0. This quadratic equation will represent two straight lines. For example, let us take the example number 1, that is x minus y plus 2 equal to 0 and 2x plus 3y minus 1 equal to 0. Combine these equations. We will get x minus y plus 2 in one bracket. In the second bracket you will get 2x minus 3y minus 1 equal to 0. So on multiplication, the product will be like this: 2x square plus xy minus 3y square plus 3x plus 7y minus 2 equal to 0. This will be the same form of the equation which I have stated earlier, that is ax square plus twice hxy plus by square plus twice gx plus twice fy plus c equal to 0. So find the area of the triangle here. The second example is to find the area of the triangle formed by y square minus 9xy plus 18x square equal to 0 and y equal to 9. This equation represents the two line, and second one, that is y is equal to 9, it is a line which is parallel to x-axis, that is y is equal to 9. So we have to find out the other two lines which has been combined with the help of factorization. You see, y square minus 9xy plus 18x square equal to 0. Here the middle term, that is 9xy, I have split it into two factors, that is y square minus 6xy minus 3xy plus 18x square. On multiplication you will get 18x square. Now take out y common from the first two terms. You will get in the bracket y minus 6x. In the second one, you take out from the third and fourth term, you take out minus 3x common. So you will get here y minus 6x equal to 0. Now here again, after taking the common factors, you will get two factors here, y minus 6x into y minus 3x equal to 0. These are the two equations of two straight lines. So equation of the three sides of the triangle are y minus 6x equal to 0, y minus 3x equal to 0 and y is equal to 9. These are the three equations of the straight lines of the sides of the triangle. By solving y minus 6x equal to 0, y minus 3x is equal to 0 on subtraction and substitution method, we can find the x is equal to 0, y is equal to 0. Now take the second, that is y is equal to 9 and y minus 6x is equal to 0. From here we will get x is equal to 3 by 2 and y is equal to 9. Now saying the third case, y is equal to 9 and y minus 3x is equal to 0. Here you will get x is equal to 3 and y is equal to 9. Therefore, the vertices of the triangles are 0, 0, 3 by 2, 9 and 3 and 9. These are the three vertices. With the help of these vertices, we can find the area of the triangle. That is, the area of the triangle will be equal to 1 by 2. The determinant is like this: 0, 0, 1, 3, 9, 1, 3 by 2, 9, 1. Take out 1 by 2 is already common. So solve it. With the help of this determinant, you will get 27 minus 27 by 2. You will get again 1 by 2 into 27 by 2. That will be the 27 by 4 square unit. This will be the area of the triangle. Now proceed to the homogeneous equation. Sum of the degree or power of x and y of each term is equal. Example criteria, that is 4x square plus 5xy plus 9y square is equal to 0. Here you see the degree of this term 4x square is, that is 2. Degree of 5xy, that is 1 plus 1, again it is 2. Degree of 6y square, again it is 2. So the degree of each term is 2. Therefore, this equation is called as homogeneous equation. Homogeneous equation of the nth degree in the variable x and y. If a function xy is a function of x and y such that function tx comma ty bracket closed is equal to t raised to power n f xy, means the function earlier, then function xy equal to 0 is called the homogeneous equation of the nth degree in variable x and y. I repeat the matter again. If xy, function of xy is a function of x and y such that if you put in place of x, if you put tx in place of y, if you put ty, then it will be equal to t raised to power n. Again the function will be fxy. Then fxy is equal to 0 is called the homogeneous equation of nth degree in the variable x and y. Let us proceed like this. Function fxy, fx and y, a0 x raised to power n plus a1 x raised to power n minus 1. You see, 1 is here, x raised to power n minus 1 into y. That is the power of y is 1 here. So here now the next term, that is a2 x raised to power n minus 2. And the power of y will be 2. The degree of y is 2 plus dash dash and ar x raised to power n minus r into y raised to power r plus dash dash a raised to power n y raised to power n. This will be our last term. Then if you just substitute function tx and ty, you see a0 t raised to power n x raised to power n plus a1 t raised to power n minus 1 x raised to power n minus 1 ty plus a2 t raised to power n minus 2 x raised to power n minus 2 and t2 y2 plus dash dash. Now the next term, that is, this is known as the general term, you can say A are t raised to power n minus r, x raised to power n minus r into t raised to power r, y raised to power r plus dash dash a raised to power n, t raised to power n, y raised to power n. You can take out t raised to power n common. You see, everywhere you will get t raised to power n. Just by using, you see here, t raised to power n minus 1 and t. So on combining these two terms, t, you will get t raised to power n. So that is why I have taken t raised to power n common. Inside the bracket you will get a raised to power 0 x raised to power n plus a raised to power 1, sorry, a1 x raised to power n minus 1 into y plus a2 x raised to power n minus 2 into y raised to power 2 plus dash a raised to power ar into x raised to power n minus r, y raised to power r plus dash a raised to power n, y raised to power n. So just if you just have a look of it, it is just equal to the same terms, that is fxy. So for this complete, you can write the function of x and y, because you just compare it, you will get the function of x and y. According to the set definition, a0 x raised to power n plus a1 x raised to power n y plus a2 x raised to power n minus 2 y2 plus so and so a raised to power r into x raised to power n minus r, ar into x raised to power n minus r, y raised to power r plus dash plus a raised to power n, y raised to power n. This is 1, and in this equation is a homogeneous equation of nth degree of x and y. You see, already it has been established in the definition also, I have mentioned it. If any function, you see, any function f x and y is a function of x and y such that if you just substitute tx and ty, then you can get t raised to power n, and the other factor will be fxy, means function of x and y. Here also you are getting t raised to power n fxy. So according to the set definition, this will be equal to 1. So it is homogeneous equations of nth degree of x and y. Now put n is equal to 2. In the above equation number 1, we get a0 x square plus a1 xy plus a2 y square equal to 0. This can be written as ax square plus twice hxy plus by square. Again, this can also be written like this. First of all, you write down this by square plus twice hxy plus ax square. So condition number 1, if a is not equal to 0 and b is also not equal to 0, and dividing it by x square both sides, we have by x whole square plus twice h y by x plus a equal to 0. This will be our second equation. It is a quadratic equation of y by x. You see, y by x raised to power 2. Here y by x means just a standard form of the quadratic equation ax square plus bx plus twice plus c equal to 0. That is the same form is there, but here in place of x I have written y by x. So y by, you see, let m1 and m2 are the two roots. Therefore y by x minus m1 into y by x minus m2 equal to 0. Just solve it. You will get y minus m1x into y minus m2x is equal to 0. This implies that y minus m1x is equal to 0 and y minus m2x is equal to 0. These are the two straight lines. Lines will pass through the origin as there are no constant term. only we are getting the x and y terms. From the equation 2, the discriminant is twice h's whole square minus 4ab, that is equal 4, take out common. Inside the bracket you will get h square minus ab. So 4 cannot be equal to 0. Now you have to compare this h square minus ab. If h square minus ab is equal to 0 at that time, h square will be equal to ab, but here you just assume that h square is greater than ab. At that time m1 and m2 be the real and unequal, or you can say distinct. That in that case the both straight lines will be real and distinct. If h square is equal to ab, means the m1 and m2, these are the two roots of the equation, these two roots will be equal and real. Both lines will be real and coincident. If third case, h square is less than ab, at that time m1 and m2 be the imaginary and both straight lines will be imaginary. This is the equation by square plus twice hxy plus ax square equal to 0. Condition number 1 we have already discussed. Now condition number 2, that is a is not equal to 0 and b is equal to 0. At that time the y terms will be vanished, y square will be vanished only, because b is equal to 0. So we will get ax square plus twice hxy equal to 0. Now take out the x common. So x inside the bracket you will get ax plus twice hy equal to 0. So the equation will represent two straight lines passing through the origin. That is x is equal to 0, ax plus 2hy equal to 0. Now the third situation or condition is a is equal to 0, b is not equal to 0. So the x square terms will be vanished from this because a is equal to 0. So 2 twice hxy plus by square is equal to 0. At that time take y common. So you will get 2hx plus by in the second bracket. The equation will represent two straight lines passing through the origin y is equal to 0. These are the equation. Y is equal to 0 and twice hx plus by equal to 0. Now the fourth condition is a is equal to 0 and b is equal to 0. At that time twice hxy is equal to 0. So xy is equal to 0. Equation will represent two straight lines passing through the origin, whose equations are y is equal to 0 and x is equal to 0. That is the x and y axis. These are the equation of x axis and y axis. So from the above four conditions, it is concluded from the above four conditions that ax square plus twice hxy plus by square equal to 0 will always represent two straight lines passing through the origin. On the basis of it, can be said that the nth degree of x and y homogeneous equations will represent n straight lines passing through the origin. Now let us find the relation between the coefficient and the slope of the line represented by ax square plus twice hxy plus by square equal to 0. This equation will represent two straight lines. Now ax square plus twice hxy plus by square equal to 0 represent the two lines passing through the origin, whose equations are y minus m1x equal to 0, y minus m2x is equal to 0. where m1 and m2 are the slope. So just therefore b into y minus m1x in first bracket, in the second bracket y minus m2x. This will be equivalent. The product of these two will be equivalent to ax square plus twice hxy plus by square. Now on multiplying left hand side, you will get b m1 m2 x square minus b m1 plus m2 in bracket closed into xy plus by square is equivalent to ax square plus twice hxy plus by square. Now comparing the coefficient of xy and x square, we have, you see, the coefficient of y square here and here both are the same, left hand side and y. Only we have to compare the coefficient of x square and xy. So we will get b m1 m2, b into m1 into m2 is equal to a, and minus b in bracket m1 plus m2 is equal to twice h. So sum of the slope can be given like this, m1 plus m2, that will be equal to minus 2h by b, minus 2h by b. So what is this? Minus coefficient of xy upon coefficient of y square. Now product of the slope, that is m1 into m2, that will be a by b, the coefficient of x square upon coefficient of y square.